Hi everyone, Permutations class 3. In this class, I will explain a few questions of CSAT based on the basic property of permutations. The number of permutations of n dissimilar objects taken r at a time is same as the number of ways of filling r distinct boxes. The number of ways of filling r distinct boxes by n distinct objects such that each box should contain exactly one object. I have discussed in the previous class. This is nothing but NPR. This is nothing but NPR. P stands for permutation. Or you can say this is n factorial by n minus r factorial. Well, here is a question asked in CSAT 2015. The same question repeated in CSAT 2023 also, just by reversing persons and the tasks. There are 5 tasks and 5 persons. Task 1 cannot be assigned to either person 1 or person. Task 2 must be assigned to either person 3 or person 4. Every person is to be assigned one task. In how many ways can the assignment be done? It is a very, very simple question based on permutations. Okay. So there will be 2 cases. First, let us write. We are assigning the task to the persons. So we write in column 1 tasks. Task 1, 2, 3, 4, 5. In column 2, we write persons P1, P2, P3, P4, P5. Okay. Let us see. First, we'll write that what are the persons and what are the tasks. Okay. This question asked in CSAT 2015. After that, I will discuss 2023 question also. Well, this is case 1. First, I will discuss one case. So, tasks, here tasks, and here persons. I'll represent tasks like T1, T2, T3, T4, and then T5. Because we are assigning the task to the persons. Here person 1, person 2, 3, 4, and then 5. 5th person. Read the question again. Task 1 cannot be assigned to either person 1 or person 2. And task 2 must be assigned to either person 3 or person 4. So first let us do assign the task 2. Assign the task 2. Right? Every person is to be assigned only one task. This is known as a 1-1 function. So here task 2, suppose assigned to person 3. Assigned to person 3. Right? Okay. Task 1 cannot be assigned either person 1 or person 2. Well, so here you see that this T1 task T1 must be assigned to either P3 or P4. T1 is assigned to P4 or P5. Because task 1 cannot be assigned either person 1 or person. So how many ways are there? There are 2 ways. There are 2 ways. Well, so already 2 persons assigned, right? 2 tasks are assigned to 2 persons. Remaining 3 tasks. Remaining 3 tasks. Remaining 3 tasks. Remaining 3 tasks can be assigned. Can be assigned to remaining 3 persons. To remaining 3 persons. Okay. Which means that we have 3 objects. We have to fill in 3 boxes. So that each box should contain 1 object. Remaining 3 persons. Can be assigned to remaining 3 persons in 3 factorial ways. In 3 factorial ways. Okay. If you assume persons as a boxes and the tasks as objects, okay. In first box, you can put any one of 3 three objects. Next second box, 2 objects. Next third box, 1 object. Well, so case 1. Case 1. There are first job is assigning task 1. First job is assigning task 1. Task 1 is assigned either P4 or P5, that is 2 ways. And the remaining tasks are assigned to remaining 3 persons in 3 factorial ways. This is equal to 12 ways. Well, okay, so this is a case 1. Yeah, this is a case 1. Case 1. Now, task 2 must be assigned to either person 3 or person 4. Task 2 is must be assigned to either person 3 or person 4. Suppose if we assign task 2 to the person 4. Person 4. We have assigned. This is case 2. All right. So this is a case 1. I have explained both case and 1 and 2 in one diagram. Now what is case 2? Case 2. Now T1 must be assigned to either P3 or P5. Either P3 or P5. Similar case, in fact, similar case, there are 2 ways. Similar case, you can multiply 12 by 2. You will get the 24 answer. So T1 must be assigned to P3 or P4. There are 2 ways. And remaining three tasks, okay, as it is, you write that in 3 factorial ways. Right? There are 3 more tasks left and 3 more persons left. Now assign 3 tasks to 3 persons. That can be done in 3 factorial ways. Well, so therefore, in case 2, there are again 2 into 3 factor. It is a symmetric case. That's equal to 12 ways. Okay. So therefore, required number of ways equal to required number of ways equal to totally 2 into 12, that's equal to 20. This is a restricted permutation. Restricted permutations means here person 1, task 1 has one constraint, task 2 has another constraint. Like that, they can increase the number of constraints. Accordingly, we can solve the question. This is a question based on purely beginning of permutations, 5 tasks versus 5 persons. Now the same question asked in 2023 CSAT exam, persons versus tasks. I'll bring that question. If you want, you can write these two cases separately. Let us see the question asked in CSAT 2023. CSAT 2023. Maybe one of the toughest CSAT exams till now. There are 5 persons P, Q, R, S, T. Each one of whom has to be assigned one task. Neither P nor Q can be assigned task 1. Task 2 must be assigned to either R or S. How many ways can the assignment be done? Question is same as the previous person. Their persons I have taken like P1, P2, P3, P4, P5. Here they have given explicitly P, Q, R, and S, T. Okay. Well, there are 5 persons, each one of whom has to be assigned one task. Neither P nor Q assigned task 1. You see, I'll write here. Here I'll write tasks. Here persons. Okay. So T1, T2, T3, T4, and then T5. Well, here P, Q, R, S, and T. Remember, first thing is that task 2 must be assigned. Must be assigned either R or S. Okay, case 1. Suppose task 2 is assigned to R. Task 2 is assigned to R. Right? Now you see that T1 should not be assigned P or Q. So T1 has to be assigned to either S or T. T1 has to be assigned to either S or T. There are 2 ways. There are 2 ways. Well, now 3 more tasks left, right? T3, T4, T5. P, Q, and one person is left on the persons. Assume he is X. Here X is either S or T. Suppose T1 is assigned to S, then X equal to T. Suppose T1 is assigned to T, then X equal to S. Right? Okay. Assume that these are the boxes. Okay, boxes. Like, and these are the objects. Well, so there are 3 factorial ways. These 3 tasks can be assigned to 3 persons in 3 factorial ways. You will get the same case. This is the case 1. Case 1. Case 2 is same as of case 1. If you assign task 2 to S, exactly same as of 2015. This is task 2. Right? So whatever number of cases you got for case 1, the same number of cases you will get for case 2 also. Right. So therefore, total required ways equal to total required ways equal to. For case 1, you got T1 is assigned, can be assigned in 2 ways. And remaining 3 can be assigned remaining persons in 3 factorial. This is for case 1. For case 2 also, you will get the same number of cases. So therefore, this is again 24. It is like a 1-to-1 mapping. 1-to-1 mapping. 1-to-1 mapping means one person must be assigned to one task. Well, I'll solve few more questions based on these simple permutations and combinations. Right. This question asked in CSAT 2023. Very simple question based on fundamental of counting principle. A flag has to be designed with 4 horizontal strips using some or all colors red, green, and yellow. Well, what is the number of different ways in which this can be done so that no 2 adjacent strips have the same colors? No 2 adjacent strips have same colors. Very good question. Actually, we have to fill that 4 horizontal strips using only 3 colors. Using only 3 colors. Okay, once you get the proper idea, it will not take more than a minute. So what is that idea? You see, we have a 3 colors, right? So let us paint the first strip. Okay, first strip. This first strip can be painted in 3 ways. 3 ways. Either red or green or yellow. Okay. Well, suppose we have painted that first strip with red. Then throw the red color. Okay. Now we have in our hand green and yellow color. Okay. So let us paint the second strip in 2 ways. We can't use all the strips, all the colors again. Okay. So first one is different, second one is different. This is using remaining 2 colors. Remaining 2 colors. Now, whatever color we have used to paint the second strip, throw it out. Now bring back the first color. Again, now we have 2 colors in our hand. The first color and remaining color. So again, the second, third strip can be filled in 2 ways. Again, I'm telling, whatever color we have used to paint the second strip, you throw it out. Okay. Bring back the first color again. We can use the first color again. Because here the question is, no 2 adjacent strips have the same color. Well, repeat this process. You can use this logic in many questions. Again, there are 2 ways. So therefore, required ways equal to 3 into 8. That's equal to 24 ways. You can increase the number of strips, you can increase the number of colors, etc. Same question can be asked for painting the wooden steps, right? Or painting the normal steps, or like painting the strips of a flag, etc. Whether they have given 3 colors, 4 colors, 5 colors, no problem at all. So you paint or you color the first strip and throw it out. Now with the remaining 2 colors, second strip can be painted in 2 ways. Now whatever color we have used for second strip, throw it out. Now bring back the first color. Now paint the third strip. That can be done in 2 ways. Repeat the same process. Whether we have 4 strips or 5 strips or 6 strips or 100 strips, no problem at all, but the process is same. How many 3-digit natural numbers without repetition of digits? Means all the digits are distinct. Are there such that each digit is odd? Each digit is odd. The number is divisible by 5. The number is divisible by 5. A number is divisible by 5 if its unit place is either 0 or 5. A number is even if its unit place is an even digit. A number is divisible by 3 if sum of the digits is a multiple of 3. A number is divisible by 4 if the last 2 digits is divisible by 4. A number is divisible by 6 if it is divisible by both 2 and 3. A number is divisible by 9 if sum of the digits is a multiple of 9. At last, a number is divisible by 7 if the units place is multiplied by 2 and then subtract from the remaining number. If that resulting number is divisible by 7, then entire number is divisible by 7. So here we have to frame 3-digit numbers. Okay, we have to frame 3-digit numbers. Frame 3-digit numbers. Using 3-digit numbers, using only odd digits 1, 3, 5, 7, 9. Only using odd digits, that too must be divisible by 3. So let us consider 3 boxes. Let us consider 3 boxes. All right. As the number must be divisible by 5, so you must fix that units place with 5. This is 5. So we have already used the number 5. Okay, remove this. Remove this. Now there are only 1, 3, 7, 9 left. Now, this box can be filled in 4 ways with 1, 3, 7, 9. And this box can be filled in 3 ways. Or directly you can write 4P2. The number of permutations of 4 objects taken 2 at it. So answer is quite simple. This is equal to 12. Here repetition of digits is not allowed. A repetition of digits is not allowed. Based on this fact, I can create some more questions. I will write now. Here are a set of questions. The number of 3-digit numbers, okay, or I'll change that the number of 4-digit numbers. All right, the number of 4-digit numbers without repetition of digits formed by 0, 1, 2, 3, 4, 5 that are divisible by 2, nothing but even numbers, divisible by 5 and divisible by 25, 4, 3. I have arranged this question in the level of difficulty order. First one is easy, second one is easy, third one is easy, fourth one is little difficult, fifth one is more difficult. Well, so first one is very simple. Here we have 0 in our digits. So we must take care of 0 because in any number, if 0 comes in the leftmost, that is not a significant digit. That is a non-significant digit. Well, so for 1, for divisible by 2, for divisible by 2. Okay. We have to divide into two cases. One case when we include 0, when we exclude 0. Okay, case 1. Here I'm writing case 1. We have to form 4-digit numbers. You fix unit place 0. You fix unit place 0. Now we have 5 digits and we have to fill 3 boxes. So these 3 boxes with 5 digits can be filled in 5P3. That's equal to 60. Right? Plus second case. What is the second case? Second case other than 0 in the unit place. If unit place is not 0, if unit place is not 0, right, this can be filled in 2 ways. That is either 2 or 4. Either 2 or 4. Okay, unit place. Now, if you remove one even digit, either 2 or 4, still we have 5 digits in our hand. But among them, 0 is one of the digits. 0 is the one of the digits. Okay. Here, we cannot put that 0. Here, we cannot put that 0. So, throw it out. Now, there are only 4 digits left. Right? 1 without 0 and 1 which we have filled in the first place. So, there are only 4 digits in our hand. So, this place can be filled in 4 ways, excluding 0. Excluding 0 and unit place digit. Okay. So we have used 2 digits out of 6. In our hand, we have 4 digits. So this place can be filled in 4 ways. Now there are 3. This place can be filled in 3 ways. Question is over. Case 1, when 0 is in unit place. Case 2, when 0 is not in unit place. So therefore, total required ways equal to. Next, we'll do divisible by 5. Total ways equal. This is 60 and the other one is 16 into 5, 80. Sorry, 16 into 6, 96. 96. That's equal to 156. Now divisible by 2 using 0, 1, 2, 3 divisible by 2. The number of 4-digit numbers divisible by, next case is 5 for divisible by 5. For divisible by 5. All right. This is simple. Okay. We have two cases. When 0 is in unit place, when 0 is in unit place, the number is divisible by 5. Well, so these are 5p3. That's equal to 16. Same as in even numbers. This is case 1. Now, case 2, less. The case 2 is when unit place is a 5. When unit place is a 5. Okay, we have to fill the remaining 3 places. Remaining 3 places. Well, anyway, exclude 0. Okay, exclude 0 and exclude 5. Now we have 4 digits in our hand. So this first place can be filled in 4 ways, means 1000 place. 2 digits we have used. Still we have 4 more digits. So this is 4. And this is 3. And this is only one case that is filled with 5. That's it. So therefore, required ways equal 60 plus 16 into 3, 48. That's equal to 108. A number is divisible by 5 if unit place is either 0 or 5. When the 0 is present in the given numbers, in the given digits, then we have to divide it into 2 cases. One is when 0 is used, and the case 2 when 0 is not used. Now, divisible by 25. Third question, divisible by 25. 4-digit numbers divisible by 25. Divisible by 25. For this, last 2 digits must be divisible by 5. Okay. Last 2 digits, 2-digit number must be divisible by 5. Must be divisible by 25. Divisible by 25. Well, here unit place must be either 0 or 5. Now take the boxes. Okay. Here also we have to use 2 cases. Case 1. When we use 0 in the last 2 places. Here you see 50, 50. Last 2-digit number is divisible by 25. Okay. So now we have 4 digits and we have to fill these 2 boxes. It can be done in 4p2. This is equal to 4 into 3 equal to 24. Plus. Here no digit being used more than once. Repetition is not at all allowed. Is there any other case? Okay. Last 2-digit number must be divisible by 5. Now, without 0, last 2 digits is 25. Last 2 digits is 25. It is divisible by 5. 25. 25 is divisible by 20. Now, we have a 0 in our hand. We cannot use that 0 in the first box. Okay, so throw the 0 out, and 2 and 5 already used. So we have only 2 more digits. Sorry, 3 more digits out of 6. So this can be filled in 3 ways. And 1, 2, 3 already used. Now bring back the 0. Now, including that 0, we have 3 digits in our hand. So therefore, 3 into 3. Is there anything else left? Let us count that the last 2 digits must be divisible by 25. So 25 table, we have to count the 25 table. 25 into 1, 25. 25 into 2, 50. 25 into 3, 75. But we don't have 7. So this case is not possible. 100 is not possible. That's over because no digit being used more than once. So there are a very few cases 4-digit numbers divisible by 25. So here the required number of ways equal to 24 plus 9 equal to 33. Now, to find the number of 4-digit numbers divisible by 4 or divisible by 4. Or divisible by 4. Last 2-digit number must be divisible by 4. Last 2-digit number means units and tens place. Last 2-digit number must be divisible by 4. Must be divisible by 4. So we want to find out all 2-digit numbers which are divisible by 4 using 0, 1, 2, 3, 4, 5. Well, we'll count the fourth table. Okay. So here I'm writing 0, 4. 4 into 1. 4 2s 0, 8. But we don't have 8. 4 3s 12. 4 4 16. We don't have 6. And next 4 5 20. 4 6 24. 4 7 28 is not there. 4 8 32. 4 9 36 is not there because 6 is not there. 40 is available. 44 is not available because no digit being repeated more than once. Next 48 is not available because 8 is not there. Next 52 is available. 56 is not available. 60 is not available. 64 more than 60 is not available. So we have 0, 4, 12, 20, 24, 32, 52. So these are the possible cases of 2-digit numbers in which that is divisible by 4. Let us divide into 2 cases, one which contains 0, one which does not contain 0. Okay. So case 1. The number of 4-digit numbers divisible by 4. All right. You take 0, 4, 2, 0, and 40. Okay. So these last 2 digits can be filled in 3 ways. There are three ways. We can fill in, there are three ways, that is either 04 or 20 or 40. Okay, so we have filled with these two boxes are filled by two digits. Out of six, already we have used two digits. There are four digits left. So we can fill the remaining two places using four digits in 4P2 ways or 4 into 3. So this is totally, this is 36 plus. Again, you take four digits. Now we have to take 12, 24, 32, 52. So the last two digits are either 12, 24, 32, 52. There are four ways. There are four ways. Those are 12, 24, 32, and then 52. Well, now here we have a 0 in our hand. Already we have used two digits for first two places. Okay, last two places, sorry. And we should not use 0 for the first box. So remove that 0. Now this box can be filled in three ways, excluding 0. Excluding 0 and first two, last two digits. Last two digits. Okay, 1, 2, 3, three boxes already filled. So we have three digits in our hand into 3. Okay, this is 4. So therefore, the required number of ways equal to required number of ways equal to first case 36 plus second case is 3 into 3 into 4. Again 36 equal to 72. The last case is left, that number of four-digit numbers divisible by 3. This is little risky question. Last, for divisible by 3. For divisible by 3. Sum of the digits must be divisible by 3. Sum of the digits, sum of the digits, sum of the digits must be divisible by 3. Must be divisible by 3. All right. So this is no doubt this is a little bit difficult. Means you will get many cases, but still we can make it simple. What is sum of given digits? 0 plus 1 plus 2 plus 3 plus 4 plus 5. All right, this is 15. Okay, this is 15. It is a multiple of, this is multiple of 15, right? A multiple of 15. A multiple of 3. 15 is a multiple of 3. So to get four-digit numbers, to get 4-digit numbers. 4-digit numbers divisible by 3. Divisible by 3. Remove 2 digits. Remove 2 digits which are whose sum is multiple of 3. Whose sum is multiple of 3. Whose sum is multiple of 3. Multiple of 3. Out of these 6 digits, remove any 2 digits whose sum is also multiple of 3. So that the remaining is divisible by number 3. Remaining 4-digit number is divisible by 3. So case 1. I'll write here some case 1. Or you can say set 1. Remove 2 digits whose sum is multiple of 3. See, I want to remove 1 and 2. So 0, 3, 4, and 5. Now I want to find that 4-digit numbers using 0, 3, 4, 5. Well, just fill that first box with 3, 4, 5. There are 3 cases. There are 3 cases, either 3 or 4 or 5. And remaining 3 boxes can be filled with the remaining 3 digits into 3 factorial. The number of ways of putting n objects into n boxes so that no box is empty is n factorial. So here you will get the 18 cases. S2. S2. Now remove that 2 and 4. 2 and 4. 0, 1, 3, 5. Right? Okay. So here also there are only using this, there are 18 numbers. There are 18 4-digit numbers. 18 4-digit numbers. Okay. There are 18 ways. There are 18 ways to form 4-digit numbers. Same as a first case. Only digits are different, but 0 is there. Time wasting. If you count every case, it is not good. Now remove 5, 4, and 5. Remove 4 and 5. Same. For this also 18 ways. There are 18 ways. Well, S4. Now remove 0 and 3. 1, 2, 4, 5. Okay. So there are 4 factorial. That's equal to 24 ways. We have to form that 4-digit numbers using 1, 2, 3, 4. Which means that the number of ways of filling 4 boxes with 4 digits, okay, is 4 factorial. First box 4 ways, second box 3 ways, third box 2 ways, fourth box 1 way. 4 into 3 into 2 into 1, that is 24 ways. I think one more case is left. Okay, I have removed that 0 and 3. 0 and 3. Is there any other case left? So here in first case we have removed 1 and 2. In second case, we have removed 2 and 4. In third case, we have removed 4 and 5. In fourth case, we have removed 0 and 3. We have to remove 2 digits from 0, 1, 2, 3, 4, 5 so that their sum is multiple of 3. First case is 0, 1, 3, 5. Oh, we have already used this case. Okay. The last case, you can remove 1 and 5. 1 and 5. So 0, 2, 3, and 4. There are 18 cases. That's it. So what are the removed numbers? First case 1, 2. Sum is 3. Second case that 2, 4. Third case that 4, 5. And the next case that 0, 3. And the last case is 1 and 5. No other case is left. So therefore, total required ways. Total required ways equal to that there are 4 18s plus 124. 72 plus 24 equal to 96. Thank you.